Hi students, welcome to Preliminary Chemistry and the water topic. This is video number 17 on calculating concentrations. So we've had a little bit of a look at the concept of molarity and the fact that there are a number of different units we can use when we're calculating concentrations. The two most common formulae that you will be using are these. Concentration is equal to the number of moles over volume, and also the number of moles is equal to mass over molar mass. Now there will be some slight changes if we're using grams per litre or if even we're using parts per million, but fundamentally these two formulae are critical, not just to your preliminary course success, but also in your HSC course. So these are two really important ones to put up somewhere where you can see them regularly and commit to memory. The important variables, of course, are the concentration, which is given by the symbol C and is usually expressed in moles per litre most commonly. The number of moles, which is just mole. The volume, which is usually in litres, and sometimes this may involve a conversion from millilitres to litres, as you'll see in the example that we have in this video. The mass, which is usually in grams, and the molar mass, which is in grams per mole, which we usually just leave as grams because we usually use 1 mole. So let's have a look at a sample question that you might be given. So here's an example of the sort of thing that we might have. We're going to make up a solution of sodium hydroxide. And we've done examples of this before, but this is the sort of information that you're often given. So you want to try and get into the habit of pulling some of the key things out of this sort of a question. So let's see if we can use a little bit of a highlighter here to do so. So we've got 20 grams here. Our 20 grams is a value that is a mass. So mass equals 20 grams. Our solute is sodium hydroxide, so we want to have that there as well. So that's going to remind us that we need to make sure that we are using our correct formula. Going to be dissolved in a small quantity of distilled water in a beaker. The contents of the beaker was stirred with a glass stirring rod and then transferred to a 500 ml volumetric flask. So we have a volume of 500 mils, which I'm going to at this point convert to litres. So 500 mils is the same as half a litre, or 0.5 litres. So we're just dividing by 1,000 here to bring it to litres. Any residue in the beaker was rinsed into the flask using a wash bottle. Now this is telling us that all of that mass has been transferred from the beaker to the volumetric flask, and so that we're not losing some of this mass. If some of that remains in the beaker and doesn't get transferred to the volumetric flask, then we won't have the full number of moles that we're hoping to calculate. Additional distilled water was added to the volumetric flask until the final volume reached, which was 500 mils. What is the concentration of this solution? Okay. So we're going to have to work our steps through with this formula, C equals N on V. The problem at the moment is we don't know N. We know that the volume is equal to 0.5 litres. So we already did that as we were reading through the question, but we don't know what the number of moles is. But we do know that the mass is 20 mils. Now the molar mass for sodium hydroxide we have to get from our periodic table. So make sure that you always have your periodic table with you so that you can follow the steps needed for these sorts of questions, but also that you can access this information very quickly and very readily. You don't have to commit it to memory, you'll get your periodic table. So the sodium is around 23, oxygen 16, and hydrogen 1. Now you'll use the exact values. I'm just rounding them up because it makes it easier for an example, but you will use 22.99 or 1.008 if that's what you're given in your table. So that means we've got a value for the molar mass of sodium hydroxide of around about 40 grams. So now we can use this equation, number of moles is mass over molar mass, to divide 20, our mass, by 40, our molar mass, to get a value of 0.5 moles. So that's the number of moles, and that's why it was important for all of that solution to be transferred across, because if we didn't rinse our beaker, then maybe some of that 0.5 moles would remain in the beaker and not get transferred to the conical flask. Now we've got our values. So our number of moles is 0.5, our volume is 0.5, so 0.5 divided by 0.5 is 0.2 0.5 moles per litre, moles, litres to the -1, or even capital M. That's the calculation. You'll do lots of examples in class, I'm sure, to help you practice with these, but these are the important steps to follow when you're calculating the concentration of a solution. Thanks for watching.